Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 6 from the October-November 2023 Pure Mathematics Paper 1 from the Cambridge 9709 syllabus. This question here is about radian measure. It says here the diagram shows a motif formed by the major arc AB of a circle with radius R and center O, and the minor arc AOB also with radius R but with center C. Okay, so one of them has a center O and it's like this over there. The other one has a center C and you've got this arc over there. The point C lies on the circle with center O. Given that ACB equals K pi radians, state the value of the fraction K. Okay, so I've got the diagram here so we can see what's happening. So we know that ACB, so let me draw the line here to make it clearer. Need a line. So if I draw this line over there, we've got to find out what this angle here is in terms of pi, right? Angle ACB. Okay, so radians basically. So we need to find what this angle over here is. Now, what I can notice here is that these two shapes are identical. Or this shape is identical. So this is like a this is like the radius. This is like the radius. Okay. And so these two are the same, these are the same, so they're all the same length. And OC is also the radius. This is also the radius. I'm going to click very well there. So this is also the radius. So basically these are two equilateral triangles. So this angle here is 60 degrees, which in radians is pi over 3, as is this angle. So you can say the angle ACB is equal to 2 times pi over 3, which is 2 over 3 pi. So therefore we can say K is equal to 2/3. Okay, because it's equilateral triangles. All right, so that's the answer to part A. All right, so it says state the value of fraction K. So I don't have to even show any steps here, to be honest, but that's the reason why that is. That's pi over 3, that's pi over 3, they're identical. So that means they must be, K must be 2/3. Okay, 60 degrees plus 60 degrees. Remember, we're doing in radians here, and pi over 3 radians is equivalent to 60 degrees. Then it says state the perimeter of the shaded motif in terms of pi and r. Okay, now you can think about this in two ways. Basically, this is exactly the same as that arc. So the reason why it says state is because you don't really have to show any steps here, because this length is the same as that length, and of course that's a whole circle, so it's going to be 2 pi r. Simple as that. You don't even, that's why it says state. All right, it's worth 1 mark. No steps need to be shown at all. Okay, you can just see that this is like symmetrical. Okay, these two are exactly the same. That's R, that's R. Okay, it's symmetrical. All right, so therefore this must be the same length as this length, and together this whole thing is 2 pi r. Okay, so that's the answer to this. We could even prove it if you wanted to. I mean, we could prove it. We could say, okay, I know that this angle, I mean, it's only worth 1 mark, so this is of course not necessary to do at all. But I know that, for example, this angle is 2 pi over 3. So we can say the arc AB is going to be, remember, the length of an arc is given by r theta. So theta here is 2 pi over 3. So it's going to be r times 2 pi over 3. Okay, r times 2 pi over 3, which is 2 pi over 3 times r. That's the length of the arc AB. And we can say the length of the, you can say the minor arc AB. The length of the major arc AB, okay, from this way around, this is, you can say this is AOB. This way around is going to be the bigger one. And see, this angle is 2 pi over 3, the same as that. Why? Because this is basically like a rhombus. All the sides are the same, the opposite angles are equal. So if this is 2 pi over 3, then this angle would be 360 minus that. So 2 pi minus 2 pi over 3, which is 4, which is going to be 6 pi over 3 minus 2 pi over 3, which is 4 pi over 3. So this angle here, from there to there, is 4 pi over 3. So if I was to work out the length of this arc, I would use r times 4 pi over 3, which gives you 4 pi over 3r. If I add them together, what do I get? I get 6 pi over 3 r, which is 2 pi r. Okay, so as I said, we don't have to actually do this calculation. This is extra. It says states with 1 mark. You should be able to see that this arc and that arc are exactly the same. So the perimeter of the shaded area, the length of its outline, is going to be altogether like a whole circle, 2 pi r. All right, so there's part B. Now for part C, it says, find the area of the shaded motif, giving your answer in terms of pi r and root 3. Okay, so now what I can see here is that this is like a sector of a circle. And this is also like a sector of a circle. And they're exactly the same because, both of them will have exactly the same area, this sector, because this sector is made up of this section over here. Okay, so this sector here is like going to be made from this part over here. So you're going to say this sector over here, this part over here, is going to be made from the sector down here. Okay, with center C. And basically this angle is 2 pi over 3, this radius is r. So the area of this sector will be the same as the area of this sector. Or the segment, sorry, I'm talking about segments. The area of this segment will be the same as the area of this segment. Why? Because this also has the same size sector on this side. Okay, this is 2 pi over 3, this is r. Okay, so therefore, if I find one of those sectors, if I find the area of one of these sectors, for example, if I find the area of this sector, and I multiply it by 2, I've got then all of this area, and then that area taken away from the area of the whole circle will give us what we're looking for, okay, which is that shaded area. So what I need to do is I need to find the shaded area is going to be the area of the whole circle, which is pi r squared, minus the area of this one of these sectors. Okay, let's say we find the area of this sector, and we multiply it by 2. Okay, so you can say, we know this angle was 2 pi over 3, 2 pi over 3. So we're going to have 2 times a half, I'll just write it like this, 2 times a half times r squared times the angle, which is 2 pi over 3 minus the sine of the angle, 2 pi over 3. Why am I writing that? Because we know the area of a sector is given by a half r squared brackets theta minus sine theta. That's the area of a sector. And where does that come from? Well, it's like you're finding the area of the area of a segment, sorry. I keep saying sector, I mean segment. Okay, the area of the segment is given by half r squared theta minus sine theta. The area of the segment is the area of the sector, the whole sector. So it's like the area of the whole of this, like you could, I'll just draw it over here to make it a bit clearer. Okay, so you have the area of the whole segment, the whole sector, okay, the whole pizza shape size. And if you take away this area, the area of the triangle, you're left with the area of the segment. So the area of the sector, take away the area of the triangle, leaves you the area of the segment. Okay, so this would be a half r squared theta, and this would be a half r squared sine theta. Why? Because this is r, this is r, this is theta. You can say the area of the triangle is a half times AB sine C. So half times r times sine of the angle between them. That's the area of the triangle. If you take the area of the triangle away from the area of the sector, you're left with the area of this segment, which is what we want. So that's where this formula comes from. A half r squared theta minus sine theta. We've got to multiply it by 2. Why? Because we have to include this sector as well, this segment as well, which has the same area as that. Okay, so there's a bit of background to what I've written down there. And then we can hopefully simplify it and have something in terms of pi, r, and root 3. So you're going to have pi r squared minus, these cancel out, so you're left with 2 times pi r squared over 3 minus, now the sine of 2 pi over 3 is root 3 over 2. Root 3 over 2 times r squared times that. And just to confirm that, okay, if we have a calculator and we make sure that it's in degree mode, in radian mode, sorry, we put sine of 2 pi over 3, which gives us root 3 over 2. Okay, so we know that's root 3 over 2. So now we can combine these together. These two can be added together. That's like pi r over, so that's like 3 pi r squared over 3 minus 2 pi r squared over 3, which is going to be just pi r squared over 3 minus root 3 times r squared over 3 over 2, sorry, not 3, over 2. Okay, so there's our answer. If you want to make it into one fraction, we can, that's fine. So some of you might have done this, made it into one fraction. So if you make it under one fraction, you have this, the common denominator of 6. So this is going to be 2 pi r squared over 6. And this is going to be 3 root 3 over 6. Okay, 3 root 3 over 6 gives us that. Yeah, so that's going to be the answer. So this is fine. This is fine. You can write it as one fraction. They didn't specify how to write it. So both of those are fine. Okay, and it's in centimeters. Is it in centimeters? They didn't give us a unit, did they? No. So we just leave it like that. That's fine. Okay, you can put square units if you want to. They didn't give us any units. But there's the answer to the question, either this or this. And that's an R there. Let me write it. My writing is a bit messy. Sorry about that. So that's pi r squared. And that's minus root 3 pi r squared. So root 3 r squared over 2. So pi r squared over 3 minus root 3 r squared over 2. That's the answer to part C. That concludes this question. And any other questions you want to see from this paper can be found in the playlist that will appear at this section over here. Questions that you want to see from this topic of radian measure from the Cambridge syllabus can be found in the playlist over here. I'll also include my playlist for my edXL material on radian measure. It's very similar kind of questions. You'll find that over here, the link for that. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.